We saw in previous videos how easy it is to crack WEP encrypted networks, even if there was no devices connected to the target network, and even if the target network was idle. We also explained a number of methods to inject packets into the traffic and cause the number of data to increase very rapidly so that we can crack the WEP key in a very short period of time. Now in the next few tutorials we're going to talk about Wpa encryption. This encryption was designed after WEP, and it was designed to address all the issues that made WEP so easy to crack. The main issue with WEP was the short initialization vector, which is sent as plain text in each packet. The short initialization vector meant that the possibilities of having a unique IV in each packet can be exhausted in active networks. So when we were injecting packets or in natural active networks, we will have more than 2 packets that have the same IV. When this happens, aircrack-ng can use statistical attacks to determine the key stream and then determine the WEP key. In WPA, however, each packet is encrypted using a unique temporary key. This means that the number of data packets that we collect is irrelevant. Even if we were able to collect 1 million packets, these packets are not useful because they do not contain any information that can help us crack the WPA key. Now I'm talking about WPA, but it's the WPA2 is the same. It works by the same method, and it can be cracked using the same methods. The only difference between WPA and WPA2 is that WPA2 uses an algorithm called CCMP for encryption. So cracking WPA or WPA2 encrypted networks, it's not simple, especially that all the packets that are sent into the air are not useful for us, as they do not contain any information that can help us determine the WPA key. Before we get into cracking WPA and WPA2, there is a feature called WPS. It allows users and clients to connect to the network by a push of a button. So on Windows 8, and if you look on some Wi-Fi printers, they have a WPS button. So if you press that WPS button and you go to your router and press the WPS button there as well, or go to the configuration page and press the WPS button, the client, the printer or your Windows device will connect to the network without having to enter the key. So the purpose of using WPS, it's a feature that allows clients to connect to the network easily without having to enter the WPA key manually. So it's just a feature in routers. This feature works and authenticates the client based using an 8-digit long PIN. So it doesn't use the actual WPA key, it uses an 8-digit PIN. This is only digits, and it's only 8 bits long, so there isn't too many possibilities for this, and if we use a brute force attack, we are guaranteed to guess this PIN. If we successfully guess this PIN, then we can use a tool called Reaver, which would calculate the WPA key from this PIN. So we're going to brute force the PIN, the 8-digit long PIN. Because it's only 8 digits, we're guaranteed to be able to brute force it successfully. Once we do that, we can calculate the WPA key using Reaver. Again, this is only a feature in routers. This flaw is not in WPA or WPA2 encryption. The problem is in the WPS feature. So let's see how we do this first. To look for access points that have WPS enabled, we're going to use a tool called wash. So I'm just going to put wash I10. So we have our test AP showing up here. That's the AP that we're going to use to crack. So this is actually running on WPA now. It's not using WIP as we saw in the previous videos. I can confirm that for you here. I'm just going to use arrow dump. This step is not important. I'm just going to use it to show you that test AP is actually using WPA encryption. It's not WEP. So as you can see here, test is using WPA encryption. Let's just go back. So these are the access points that have WPS enabled, that have the WPS feature enabled. We can see the channel, the RSSI, which is the the distance between us and the access point, the WPS version, and this WPS locked. Now, some routers, when you try to brute force the WPS pin, they lock after a few failed attempts. So if you try, for example, 4 wrong pins, they're gonna lock and not accept any pins for a certain amount of time. So if the WPS locked says yes here, then you can't actually use this attack now, so you need to wait for a little bit and come back to this access point. So we're gonna launch Reaver now. Reaver is going to brute force the WPS pin, and once it's able to find the WPS pin, it's going to work out the WPA key. Reaver supports pause and resume, so if you for example brute force 30% of the possibilities and cancel the attack, if you come back, you're gonna start again from 30,000. You're not gonna start from 0. So let's launch Reaver. We're gonna put B to choose the BSS ID or the MAC address of the target access point, and then C to choose the channel, which is 11, and then I and choose the Wi-Fi card with monitor mode, and that's 10. So very simple. Reaver, access point, BSS ID, channel, and then the Wi-Fi card with monitor mode. Gonna hit enter, and now Reaver associated with the target access point. It tried to determine the WPS pin. Now I have an easy pin, which is 1234567, and from that it was able to calculate my WPA key. So that's the WPA key, UAURWSXR, and that's just the name of the access point. So I can just come now and connect to my network, and if I put the key that we just found, I'm going to show the password, and it's UAURWSXR, connect, and as you can see, we connected successfully to the network. Now there's a few options that I'd like to show you for Reaver. I'm just going to go Reaver, help, and that's all the options that you can use with Reaver. So as I said, some routers would lock after a few failed attempts. Therefore, you can use some of these advanced options to get Reaver to work against these access points. For example, you can use the delay option and specify the amount of time in seconds that Reaver should wait between each brute force attempt or each pin attempt. You can also use the lock delay to tell Reaver to wait, for example, 60 seconds after if the access points gets locked, then wait for 60 seconds and then continue your brute force attempt. You can use the fail wait as well to set the time that Reaver should wait after 10 failed attempts. You can use the OR option to tell Reaver to sleep after a certain amount, to sleep for a certain amount of seconds after a certain number of tries. You can set up the timeout. You can play with these options, the delay options, and the timeout, the fail wait, and all that if the access point was locking or was ignoring some of your brute force attempts.
Previously, we've seen how we can use Reaver to crack the WPS pin and from it get the WPA key. We've seen the basic usage against a router that's not very secure. Now, like I said, that router was given to me by the internet provider with these default settings. So most people will actually leave it at these settings, and it'll be as easy as that to exploit all the networks that use these routers unless the user went and manually changed the settings. Now in this lecture, I want to show you another example of a more secure router. So this is another router that I have in here, and I want to run Reaver against it, and we'll see how we can crack its pin and get the password. So first of all, we're going to have to run wash to see all the WPS enabled routers against me. So we're going to do wash I mon0. So this is exactly the same command that we were running before. Mon0 is my wireless adapter in monitor mode. I'm going to hit enter. And as you can see, I have all the WPS enabled routers around me. Now my target in this video is going to be this one, which is called test ap2, and it has this MAC address. So like we did before, I'm going to first copy this, and I'm going to run the basic reaver command that we used previously. So it's just going to be reaver bssid, then give it the channel, which is 11, and then we'll give it my wireless adapter in monitor mode, which is mon0. So a very basic command that we've seen before. We're just doing reaver, we're giving it the bssid of the target network, then we're giving it the channel of that network as well, and then we are giving it my wireless card in monitor mode. I'm gonna hit enter. Now I've actually executed this command before, so it's asking me, do I want to continue from where I left in the last time? Do I want to restore my session? I'm gonna say no, because I want you to see what's gonna happen. So we're assuming that we're starting from scratch. And as you can see, it keeps saying failed to associate with my MAC address. And this message will keep continuing to show in here. So we'll basically just be stuck in here, and we're just not going to get any results at all. So I'm going to first Control-C out of this. Now to fix this issue, we're going to manually associate with this access point. So I actually covered before in a full lecture how to run a fake authentication attack. This is exactly what they mean here by association. So what we're going to do, we're gonna manually associate with the target using AirPlay NG, and then we'll run reaver again and tell it not to associate, because we're gonna do that manually. So we'll just tell reaver to do the rest of the things that you usually do, but don't associate this time, because I'm gonna do that manually. So I'm gonna split the screen, and I'm gonna run AirPlay NG here to associate with my target. So I'm gonna do AirPlay NG, I'm gonna do -- fake auth to associate with the target to do a fake authentication attack. Then I'm gonna have to give the delay, and previously we used to give this at 0 because we don't do this for a long period of time, so we usually don't need to stay associated with the target for a long period of time. In this example, we want to be associated with the target for as long as the time when reaver is working. So I'm going to set this to 100, and what this is going to do, it'll basically set a delay of 100 seconds between the association attempts, between the time when AirPlay NG sent the fake authentication packets. Next, I'm going to have to give the MAC address of the target access point. So we're going to do -A and give the MAC address. Then I'm going to have to give the MAC address of my own wireless card, and we'll do that using the -H option. And to get my MAC address, I'm going to have to split the screen again and do ifconfig mon0. So we're doing ifconfig followed by the name of your wireless adapter in monitor mode. I'm going to hit enter, and under the unspec, this is your MAC address. So it's the first 12 digits of the unspec field. So in here, to type it, this is going to be 00 C0 CA 828298. Finally, we'll type the name of my wireless adapter in monitor mode, which is mon0. So I'm going to close this here. And I'm just going to go over the command one more time. So the whole idea of doing this command is so that I can manually associate with my target, because as you can see here, reaver is failing to associate. It can't associate with my target. Therefore, it can't go and start brute forcing the pin. So we're going to do this manually here. We're doing it using AirPlay NG. We're telling AirPlay NG that I want you to do a fake authentication attack to associate with my target. I want you to use a delay of 100 seconds between the association attempts. I want the MAC address of the target access point to be this one. And my own MAC address is this one. And this is my wireless adapter in monitor mode. Now this is all good. Now we need to go back to Reaver, and whenever we're gonna run Reaver, we're gonna use the exact same command that we ran previously. The only thing is I'm gonna do -A. Now I didn't discover this myself. If you just do Reaver --help, you'll see all the options that you can use with Reaver, including the -A, and you'll see a description that you can use this to tell Reaver not to associate with the target. So we'll run Reaver like that now. And this is asking me if I want to restore my session. I'm gonna say no. And then as soon as I hit enter, I'm gonna go down here and start the fake authentication process. So I'm gonna hit enter here, go down here, hit enter, and let's see what's gonna happen. And perfect, now we managed to bypass this issue. We managed to bypass the association issue because as you can see, it's saying that it's associated. And it looks like it's trying to guess it, but for some reason we're not moving ahead. We're still stuck at 0.00%. So for now we actually bypassed the association problem, and in the next lecture I'll show you how to debug and tackle the other problem that we're facing. Okay, now in the previous lecture we seen how we can fix the association problem if Reaver could not associate with the target and was just giving you the fail to associate problem in here, and we seen how we can fix that by manually associating with the target. Now in many cases that's it, that'll be the end of the issue. So that was a completely separate issue that we solved. The problem is after we solved that issue, we ran Reaver, we bypassed that issue, but we were kind of stuck at 0.00% and Reaver wasn't moving, it wasn't giving us any information, so we really didn't know what to do, so we're kind of stuck on what's the next step. So what I want to show you in this lecture is a way of debugging and knowing what's happening in the background, and we'll see how to bypass the issue that's actually happening. So first of all, before I start trying solutions, I want to know what's happening in the background. And to do that, we're going to run the exact same command using the exact same sequence that we were doing before, but I'm going to add one more argument to the command, and that is -vvv. And what this does, it basically tells Reaver to produce verbose output, which means that it'll give us as much information as possible about what's happening in the background. Now we usually don't use this option because you'll see the screen will get filled with messages and it'll be hard to track what's happening. But if you're getting stuck, this is the only way for you to debug and know what's happening. So I'm gonna hit enter for this, and it's asking me if I want to continue. I'm gonna say no because I like to always start from scratch, especially if I didn't make any progress. And before I do that, I'll get my command ready here, and I'm gonna hit enter here, go back here, hit enter to associate, and let's see what's happening. So I'm gonna let this run for a little bit, and then I'm gonna Control-C out of it, obviously, because we know this is actually not gonna work. And once we stop, we're gonna analyze the output and see what's happening. But as you can see, it's producing a lot of output, and that's why we usually don't use the -vvv, because if things are going well, we actually don't need to see these messages. Okay, now I think this is enough for us to know what's happening. So I'm just gonna Control-C here, and I'm gonna Control-C in here. I'm gonna bring this down a little bit so we can focus on the top. So we can see the start here. We can see that it associated here with no problems, so that's all good. And we can see this is the first pin that it's guessing, so it's 000555673. Now it's sending the requests, and as you can see, it's getting a timeout error. Now let's keep going and see what's happening. Now we can see after sending the NAC packets, we're getting a message saying WPS transaction failed, and it's gonna try the last pin. So it doesn't know whether this pin is valid or not, so it's just gonna try the exact same pin again. looking back at what's happening, the same thing happens. It sends a WSC NAC, and then again the same thing happens. The transaction fails, goes back to trying the same exact pin. Go down and you see the same thing happening, and it's still trying the same pin. Now, looking at this, let's look at the help. So let's do rever --help. This will show us all the options that we can use with rever. And if you look in here, you'll see we have an option of capital N or -- no NACs. And what this does, it tells rever not to send NAC messages when out of order packets are received. Now looking at the output here, at the way that rever keeps receiving these packets, and then it's repeating the same thing because it's sending the WSC NAC, we can try to tell rever not to send this NAC and just keep trying and see if this actually fixes the problem, because it looks like it's the WSC NAC packets that's causing rever to get stuck in this loop. So I'm gonna run the exact same command again, and this time we're adding one more argument and we're saying no NACs. Okay, so I'm gonna hit enter. Again, I'm gonna say no to start from scratch, and I'm gonna prepare my command here. So enter, enter, and let's see what happens. Now rever is trying this pin, which is 0005678. Let's see if the next pin is going to be different. Now I already know this pin is different than the first one because I noticed the first one, but let's see. And boom, yeah, next pin is different. Now it's 01235 678, and again a new pin. So we're doing 1115670. And perfect. So far rever has tried 4 pins and it's actually making progress. So we're not stuck at where we were. We managed to bypass the 0x2 and 0x3 issues, and now we can just let rever work and brute force the password for me. Now it detected AP rate limiting, which is another issue that I'm gonna cover later, but for now we managed to bypass the 0x2 and 0x3 issue. So the take-home lesson from this lecture is you can do the -VVV to debug and see exactly what's happening in the background. You can do --help to see the options, and we've seen how we can use the no NACs to bypass the 0x2 and 0x3 issues. Now I want to note that each of these issues, now the router I have right now is a very stubborn one. So probably you might not face all of these issues that I'm covering now in a router. For example, you might face the issue that I covered previously about the association, but everything will run smoothly after that. Or maybe you could associate with no problem, you won't need to manually associate, but you'll get stuck after that and you'll have to run VVV, see what's happening, and then maybe use no NACs like I showed you. Or maybe you won't face any of these issues and you might jump straight to the rate limiting issue that we're getting right now, and that I said I'm gonna cover later. So each of these issues, I'm putting them in a different lecture because you might only face one of them. And obviously there might be the case where you face 2 or 3 of them like I'm showing you right now. But the idea is you might actually only face one of these, and I want you to understand how to bypass each one of these issues individually instead of just giving you a long rever command that'll bypass or that'll try to bypass most issues. Now the attack that we seen in the previous video worked perfectly because the pin was really simple. It was set to 1234567 and it actually came from the factory like this, so most people will not be modifying that, and if your target is using the same router that I got from my internet provider, then you'll be able to crack their password very easily. Right now I just want to show you an example. I actually modified the router settings and I set the pin to be something more random. Again, it still has to be 8 digits and still has to be made out of digits only, so you'll still be able to cover all possibilities and crack it. And I just want to show you that this still works if the pin was more complicated than just 1234567. So I'm just going to run wash again. And we can see that I have my target here, the test AP. And I'm just going to run Reaver against it exactly like I did in the previous lecture. Give it the BSS ID and the channel and my wireless interface. I'm going to hit enter. And Reaver actually supports pause and resume. So if you were cracking a network and you reached 50% for example, and then you wanted to stop that attack for some reason, you can just press Ctrl+C at the same time, go do whatever you wanted to do and come back even weeks after and just launch Reaver again against that network, and Reaver will know where it stopped and it will start from 50%, so it's not going to start from scratch. So with this I'm going to tell it yes, please resume, and it's going to start with me. So you can see that so far it tried 25 pins. And it's just going to keep going, and it's going to try to brute force all possibilities. And if we look at the start, you'll remember that it said there's 11,000 possibilities. So it can actually cover all these possibilities. It's not a huge number. And then when it covers all of them, it will definitely be able to get the pin and then calculate the key from the pin. Now I'm going to Ctrl+C out of this because this is actually working properly, and I just wanted to show you what it would look like while it's working if the pin was a bit more complicated. So you can see right here it reached 0.37%, and it's saying that the estimated maximum time is 6 hours 5 minutes to cover all possibilities. So you might actually be able to guess the pin before that time and get the key, but the maximum time that you're gonna have to wait is 6 hours 5 minutes and 18 seconds. Now if I go up, now notice that it's 0.37%. If I go up, you'll see that I was at 0.33%. So it's actually working. It's trying the pins, it's going through the pins and trying them one by one individually. So everything is working. All I have to do in this case is just wait for it to guess the pin and then give me the key. Now this router is configured in a way that it's gonna accept failed attempts and it will never lock. So when we run wash, I'm just gonna go and run wash again like I did. You'll see the WPS locked here, and for my test AP, it's still set to no. What this basically means is some routers lock after a number of failed attempts. So when you try to authenticate with them using a wrong pin after 4, 5, 6, however the router is configured, they will lock and they'll stop accepting any requests even if we try the right pin. So the router that I'm trying against right now, the test AP, never locks. Even if I try 1,000 wrong pins, it'll never lock. So that's really handy, and that's why it's very easy to crack. While you're testing, you might face some routers that are configured to lock after a number of failed attempts. And once the router locks, basically you won't be able to do anything, and you'll have to wait for it until it unlocks. Some routers unlock after a minute, some routers lock after 5 minutes, and some routers take days to unlock. So it's not really a good idea to just sit down and wait for the router to unlock. Now my other router, the updated one that's sent from the company, actually does lock after failed attempts. And I'm going to show you now. I'm just going to run Reaver against it, and I'm going to show you how the router looks like if it's locked. So my other router is actually the one that I'm using currently, so it's still named the default name. And it's this one. So I'm going to run Reaver against it again using the same command that we did in the previous lecture. I'm not going to do anything fancy. So it's just going to be, I'm going to clear this first, and then I'm going to do Reaver -B, and it's running on channel 6. And then I'm going to give it my wireless card in monitor mode, hit enter. Sorry, I had to give it after -I. And again, it's asking me if I wanted to continue from the last time. I'm going to say no to start from scratch. And you can see that it works for a bit, and then it just completely locks. It doesn't really do anything. It just sits down there. Now if I press Ctrl+C and run wash again, you'll see that the router got locked right here. And it won't accept any more requests right now, so we can't really do anything at the moment because WPS is locked. Now the simplest way to get the router to unlock is to just de-authenticate all the connected computers and keep doing that for a long period of time until the user, one of the users, will just think that there is something happening in the network and just goes in and turn off the router and turn it back on. When they do that, the router will get unlocked and then you'll be able to run Reaver again. So to do that, all you have to do is do an authentication attack like we did before. So you're going to do reply-ng deauth. You're going to give it the access point. And you're not going to specify a client because you want it to connect all the clients. And then you're going to give it the card in monitor mode, which is mon0. And don't forget to specify a really large number after the deauth. Now we spoke about this before and I'm not going to run this attack right now because it actually requires physical interaction of the user to go and restart the router. So again, it's not the best way, but it is a way to get the router to restart. There's better methods to do that. We're going to do them using a tool called MDK3 and we'll talk about them in the next lecture. So in the previous lecture, we've seen if we run Reaver against this particular network, the network will get locked and we won't be able to brute force the WPS pin because the network will just refuse any requests. So we said one of the ways to try and reset or get the network to get unlocked is to just run a de-authentication attack like we did before and hope that one of the users will just go in and physically turn off the router and then turn it back on. And we said this is not a great way because we actually were relying on a person to go and turn off the router. But it has a high chance of success because what would you do when you lose internet connection? Most people would just go and turn off their router and turn it back on. So in this lecture we're going to use a tool called MDK3 and we're going to use it to run a DDoS attack, a denial of service attack basically, on the target network. And in some routers, this attack will just flood the router and then it'll cause the router to reset automatically. And then when it resets, it will get unlocked as well. So we'll be able to run Reaver and start guessing the WPS pin again. And since Reaver supports pause and resume, this can work really well. So even if you're at 60% and then the router locks, you can just Control-C Reaver, run this attack, get the router to be unlocked, and then run the attack again, and it'll start from 60%. It's not going to start from 0. So I'm just going to split the screen here. And I'm just going to run the tool that we're going to be using. It's called MDK3. And I'm going to type in help just to see the options that this tool gives us. And you can see that this tool actually let us run a number of attacks and the test modes are listed in here. So the way the tool works is you specify the name of the tool, you follow it up with your interface in monitor mode, and then you follow it with the test mode, which are listed in here, and then you give it the options for each of these test modes. For this lecture, we're going to be using the A option, which is the authentication DOS mode. So to see all the options and get more information about this attack, we're going to do MDK3 --help and then put the test mode, which is A. So I'm just going to do MDK3 --help and then I'm going to put A. And this will give us more information about the attack that we want to do. So it's going to be an authentication DOS mode. It's going to send authentication frames to the AP. So basically what it's going to do is we're going to specify a MAC address for our target, and MDK3 will create fake MAC addresses and get all of these MAC addresses to pretend as if they're computers or clients, and these clients are trying to connect to that network. When there is a very large number of clients trying to connect to one network, to one router, some routers will not be able to handle all this demand and they'll actually just restart and reset everything. And when they do that, they'll unlock WPS and we'll be able to run Reaver again. So if you run MDK3 with the A option, it'll do that on all the networks around you. So it's going to create a very large number of clients and it's going to get all of these clients to connect to all the networks around you. and we don't want that. We only want to target one network. So we're gonna specify the target network with the -a option to specify the target MAC. And we're also gonna use -m to tell it that we want you to use valid MACs, so MACs of actual devices, instead of using a MAC that looks like it's fake, like 000000. So let's run the command. Let me show you the command that we're going to use, and things are going to get more clear. So the program that we're going to use is called MDK3. Then we're going to give it the interface in monitor mode, and it's 10 in my case. Then we're going to give it the test mode or the attack mode, and that's the authentication DOS mode, so that's going to be A. And then we want to run that against only one specific router, not all routers, so we're going to specify the -a and give it the MAC address of my target router, which is the same MAC address in here. It's the same MAC address that's locked in here, right here. And then we're going to give it -m to tell it to use valid MAC addresses instead of just ones that look wrong. So we're going to do -m, and that's it. We're ready to go. So we're just going to go over the command one more time. We're using a tool called MDK3. We're giving it the interface in monitor mode. In my case, it's mon0. We're telling it we want to use the attack that's referred to with the A option, which is the authentication DOS mode. We're giving it my target access point after the -a, and then I'm giving it -m to use valid MAC addresses. I'm gonna hit enter, and I actually misspelled MDK3. I said MKD3. I do that a lot. So it's MDK3. Hit enter, and you might see a result like this saying that the target router does not seem to be vulnerable, but just let it work. Sometimes you might have to let it work up to 50,000 clients. You can see that it's creating fake clients and it's trying to get them to connect to the router, so you can to associate with the router, really, not connect. And you can see that we reached 5,000 clients right here. This could be different from one router to another. So sometimes I had to let this go up to 50,000. In this case, with my home router right here, it usually resets between 5,000 and 10,000. So I'm just going to let it go up to 10,000 in this case. And once it's at 10,000 like this, I'm going to Control-C at the same time to get out of this. And we're going to run wash again to see if the network is still locked. So you can see the last time we ran wash, the network was locked. So I'm just going to give it some time to reset. And then I'm just going to be running wash. The same command that we always use is just wash -i mon0. And keep in mind, this doesn't work against all routers, but it works against a lot of routers really, but not all. So it might not just work for you. So I'm going to hit enter now to look for networks around me. Looks like something went wrong with my wireless card. So I'm just going to disconnect it, reconnect it, enable monitor mode, and run wash again. Okay, so I'm just going to run wash again here. And as you can see now, our target network got reset, and you can see that WPS is not locked anymore. So I can actually start Reaver again, and it will be able to pick up from where it left the last time. So last time the pin count was left at 0, and right now if I run it again, I'll be able to go to pin count 1, so I'll actually be able to test one more pin. So if we just do Reaver again using the same command that we did before, you can see that it's asking me if I want to continue from where I left the last time. I'm going to say yes please. Now again, the router got locked again right now, but you can see that we managed to go ahead with one more pin to test one pin right now. And if we do the same now, get the router to unlock and do the same, you'll be able to go to the next pin. Now this network is actually a quite stubborn one. Usually networks lock after 4 or sometimes even 10 attempts. Very rarely they'd lock after one attempt only. But again, this just serves with our examples. The main thing is you can unlock most networks using this method using MDK3.